Dear students, in the last video we discussed about mean value theorem. So let us solve a question. I have already written the question. Does the given function satisfy the hypothesis of mean value theorem on the given interval? If yes, find C. Fx is equal to square root of x minus 1, closed interval 1, 3. So first we have to check whether the two conditions of the mean value theorem are satisfied or no. If both the conditions are satisfied, then we will find the value of C. So let us solve this question. First we will discuss condition number 1, that is the function fx should be continuous on the closed interval ab. Here the function is square root x minus 1 and the interval is closed interval 1, 3. We can say that the function fx is equal to x minus 1 square root is discontinuous when x minus 1 is less than 0. In this case, x minus 1 becomes a negative number, and we know that square root of a negative number is not defined in real numbers. This gives us that fx is discontinuous if x is less than 1. But if you observe, we are discussing the continuity of square root of x minus 1 on the closed interval 1, 3. And these points x less than 1 are not in the interval 1, 3 closed. So we can write that these points of discontinuity are out of the interval 1, 3 closed. And hence we have no problem in saying that fx is continuous on the closed interval 1, 3. Now let us go to the second condition. In the second condition, we will discuss the differentiability of the function fx on the open interval ab. So first let us differentiate the function and then we will investigate. Here the function fx is square root of x minus 1, and using chain rule we can say that f prime x will be equal to 1 by 2 square root of x minus 1 multiplied by 1, so that will remain same. If we observe f prime we can easily say that f prime does not exist only when x minus 1 is less than 0 or equal to 0. If x minus 1 is less than 0, f prime will contain square root of a negative number, and square root of a negative number is not defined in real numbers. Second point, if x minus 1 is equal to 0, f prime will contain the denominator as 0. F prime will become 1 divided by 0, and we know that division by 0 is not defined. This implies that x is less than or equal to 1. But we are discussing the differentiability of the function fx is equal to square root of x minus 1 on the open interval 1, 3. So we can write that these points when x is less than or equal to 1 are out of the open interval 1, 3. So there is no problem in saying that the function fx is differentiable on the open interval 1, 3. And hence we can say that both the conditions of the mean value theorem are satisfied, and therefore we can go on to calculate the value of C. Now we will write that the hypothesis of mean value theorem are satisfied. This implies there is a C in the open interval 1, 3 such that f prime C will be equal to fb, that is 3, minus fa, that is 1, divided by b, that is 3, minus a, that is 1. We have already calculated f prime x, that is 1 by 2 square root of x minus 1. Using this, we can write that f prime C will be 1 by 2 square root of C minus 1. This is equal to the function fx is square root of x minus 1. Therefore, f 3 will be square root of 3 minus 1 minus f1, that will be square root of 1 minus 1 divided by 3 minus 1, that is 2. Now we will simplify. 1 by 2 square root c minus 1, that will be equal to square root of 2 minus 0 over 2. Now let us cross multiply. Two cancels with 2. Let us square both sides. So 1 by square root of 2 is equal to square root of c minus 1 whole square whole square. This will give us 1 by 2 is equal to c minus 1, and this gives us c is equal to 1 by 2 plus 1, and this gives us that c is equal to 3 by 2.